to review the energy density problem on the last assessment and show you how the math works on that one. And there was multiple problems within this problem. So you need to have your assessment out in front of you so you can read the problem. It says, calculate the energy density of the following scenario. You have 100 grams of methane, which is natural gas used in city buses and some cars, is fully combusted and raises the temperature of 1 kilogram of water by 15 degrees Celsius in a calorimeter system. 100 grams of methanol, which is a fuel for high-performance vehicles, is fully combusted and raises the temperature of 1 kilogram of water by 526 degrees Celsius. You notice in this problem I gave you two separate problems. The first is for methane, and the second is methanol. In an energy density problem, you're figuring out how much energy is transferred by the fuel to heat up water, and you're making the assumption that the energy transferred from the fuel to heat up the water is all of the energy given off by the fuel. Therefore, that is the energy of the fuel. So what we have to do for each of these is calculate Q of water and then divide it by the mass of the fuel used. So let's start with methane. So it says we have 100 grams of methane. I don't use that value right now. It's fully combusted and raises the temperature of 1 kilogram of water. So on the bottom of the problem, I told you that 1 kilogram equals 1,000 grams. You need to use 1,000 grams. The specific heat of water is 4.184 joules gram Celsius. And I do not give you a delta T to calculate, therefore you make the assumption that the temperature I did give you is the delta T. So the delta T is 15 degrees Celsius. It's 1,000 times 4.184 times 1,315 degrees Celsius, and you're going to get a really big number, which makes sense because all of these are kind of big numbers. So Q equals 5501960, and those are joules. Grams cancels out with grams, Celsius cancels out with Celsius. Well, energy density has the units joules divided by grams. So what you would do next is this is the energy produced by the combustion of methane. Well, I used 100 grams of methane, so I would take this value, divide by 100, and this number is the energy density. So 55,020 joules per gram, or you could say 55 kilojoules per gram. This is the energy density of methane. The second one was methanol. Again, you heated up 1,000 grams of water, or 1 kilogram. The specific heat of water is 4.184 joules gram Celsius. And when you combusted methanol, it only heated up the water 526 degrees Celsius. So automatically, just based on the temperature differences, I can determine that methane is a more energy dense fuel because it heated up the water more. But let's calculate that. So 1,000 grams of water times the specific heat of water times the delta T of water. So again, get me a big number. So Q equals 2200784 joules. And this is just how much energy was released by the methanol, but we need to figure out the energy density, which is joules per gram, or kilojoules per gram. So I need to divide by the mass of the fuel burned. So divided by 100 equals 22,000. I'll just round that up to 8 joules per gram, or 22 kilojoules per gram. So energy density, you want to have a higher amount of energy per gram of substance. Therefore, methane is the fuel with a higher energy density. And it says the last question, if you had to choose a fuel for your car based on energy density, which would you choose? You would want the one that produces more energy. So you would pick methane because it produces over double the energy that methanol does.